Well, certainly the need to produce more food is there. Some estimates say double our food production by 2050, others say 70%. I don't think the actual figures matter very much. It's the magnitude. We need to produce a lot more food because there's going to be lots more people. That's one point. The second, actually more important point is that the world is becoming an increasingly urban society. Urban societies, people who live in these urban societies, have more disposable income. So they want to eat more different kinds of food, especially high protein food, also very diverse food that comes from exotic places, which means that countries have to import. So a key challenge to most of us really is what we call the physical access to food. Being able to have good transport systems that assure the food gets from the source to the consumer in a reasonable time at low cost, but also in a safe condition. And that's really where food safety comes in. In the past, we never used to worry very much when talking about food security, about food safety. Today, we need to think about the multiple dimensions of food security. So food security is not just growing enough food, it's about food safety, it's about nutritious food. Now, as the figures show us, in the world today, over 800 million people are undernourished. In the ASEAN region alone, 1 in every 10 people go to bed hungry. So that means as a region, we're not food secure. So the challenges facing us are to really expand our view of food security, not just producing more food, looking at how food gets transported, looking at affordability of food, making sure that in fact everybody, every household can afford to buy food. And then of course lastly, food safety, nutrition and the aspects as well. Food waste and food loss have both become part of the equation to provide more food to the human population. I think in the early days, we used to worry about just producing more food and not worry too much about losses. Now, today we have so much information to show that in the developing countries of the world, we could be losing up to half the food that's been grown. In the developed countries, we are wasting food. Up to 30 to 40% of the food is wasted. And there's an important difference between food loss and food waste. Food waste usually occurs in the developed countries, and usually after the food has been processed and is at the consumer. Whereas food loss usually occurs at the planting stage, the farmer stage, and also in the processing stage, just before the consumer gets it. So food loss can be avoided through better technology, for example, through cold chain management. Food waste is actually more difficult, but it's just as significant. For a country like Singapore and other developed countries, food waste can best be addressed by education, educating the consumer to accept food that may not be the best looking, but yet is still edible.
Many people have heard of test tube meat, insect protein, and microbial protein. So let me touch on these few examples one by one. For test tube meat, it is very innovative in the sense that you don't need an animal to get a beef steak. However, technical challenges remain. These include how to reproduce the texture and the taste of the real beef steak, and how to maintain the consistency because we are talking about culturing animal cells, muscle cells, or stem cells in the lab environment. Even in a scale-up setup, like in the bioreactor, we need to maintain the consistency. But by and large, this is a very innovative alternative in the sense that there's no genetic engineering component in it, so everything is natural, and we save a lot of resources in raising the animals, things like that. So this is one example. The second example is insect protein. While insect protein as an alternative food supply has been recently actively championed by the UN, because this provide an obvious alternative for the poor country in supplying the sufficient protein to the children and the general population in these developing countries. Well, actually, there's value in this proposition in the sense that insects, as compared to the livestock animals, they are far more resilient. They grow faster. The feedstock is far more diverse than the cow, for example. Another advantage of using insect as alternate food supply is that you can grow them vertically, 3D, just like vegetable. So urban farming is the same idea. So they grow much faster than the traditional livestock like cattle, all these things. And importantly, the insect protein value and lipid value is comparable to what we have been eating from animal meat. There's another type of alternate food supply or protein supply is in the form of microbial protein. So where can you find this microbial protein? Well, everyone knows that they are, in addition to trees and green leaf plants that can absorb CO2 to grow, there are also microbes like algae and bacteria that they can also absorb the CO2 and for their growth. So in this context, we can use microalgae as alternative protein supply. Microalgae has various properties. Some of them can store very high proportion of lipid. Some others can store high proportion in protein. So you have two alternate food supply, one for the protein, the other one for the lipid. Another type of microbial protein or food supply will be in the form of microbe that can convert all the gases into protein. Why is it important? As we know, traditionally microbes, they take in glucose for their growth. The glucose is basically hydrocarbon molecules. Singapore has a large petrochemical industry, so we should think of tapping on this huge infrastructure and in time of need produce protein and food supply using microbial conversion.